Okay, guys, what we're talking about this week is we're talking about expressing roots and the laws of exponents. Okay. What we're going to do with expressing roots is the first thing we've got to understand is what is a perfect square compared to one that's not a perfect square. Okay, and we've talked a lot about perfect squares. For example, 1. If you have one side and the width is 1, this is the square root of 1 is 1. Okay?
No, that works.
Now, the second one we have is 4 blocks. If I have 4 blocks, okay, this is actually the square root of 4 equals 2. Okay, and the way we've remembered it in class is if it has 2 sides, if there's 2 on the side, it is going to be equal to the whole number 2. So the square root of 4 is 2. And the last one that we've really done, just because I run out of blocks, is 9. Okay? So if I have 9 blocks, I have a perfect square as well. Okay? So here's that perfect square. I have 9 blocks right here. Now, what we're going to talk about in this section is, what if I only had 8 blocks? What would my square be? Because if I have 8 blocks, the squares are not going to be, they're not going to be exactly 1 by 1 by 1. They're going to be decimals. And what we're doing with radicals is we're talking about decimal numbers. So, but the first thing we need to do is we need to know what our perfect squares are. Okay? So, up to 100, we have 10 perfect squares within there. And you're going to start finding a pattern. Okay? The perfect square of a square that is 1 width by 1 height is equal to 1. 1 times 1 is 1. If it has a width of 2 and a height of 2, it is going to be 4. If it has a width of 3 and a height of 3, it's going to be 9. A width of 4 and a height of 4, it's going to be 16. So really all we're doing is we're multiplying like numbers. Okay? So the next one would be 5 times 5 equals 25. 6 times 6 equals 36. 7 times 7 equals 49. 8 times 8 equals 64. 9 times 9 equals 81. And 10 times 10 equals 100. Okay, so those are our perfect squares up to 100. So let me write them down differently. We have 1, we have 4, we have 9, we have 16, we have 25, we have 36, 49, 64, 81, and 100. All of these, if they're in radical form, will be perfect squares. Okay? So here we go. Let's do the first homework problem. The first homework problem is the square root of 88. Okay? You have the number 88 in the radicand. Okay? So we're going to draw a radical symbol. 88 is the radicand. And we are going to now use what I call prime numbers. Alright? Prime numbers are 2, 3, 5, 7, and 11. 13, and there's many more. But we're really going to focus in on 2, 3, 5, and 7. Okay, those are typically the ones we're going to see. We might see some others, but let's focus on those at first. The reason I do this is because I know you guys know how to do prime factorization. If we can do prime factorization, then we are going to find pairs of numbers, and we are going to take them out of the radicand. So let's try it with 88. So 88, we can divide that by 2. 2 times 44 gives me 88. And all I did there was simply do 88 divided by 2, and I got 44. Okay? It will take you a little bit of long division to find this out. But as you do it more, you'll get better. Alright? Then with 44, we're going to go 2 times 22. Okay? And again, all we're doing is we're doing 2 divided by 44, and 2 goes into 4 twice. 2 goes into 4 twice, and gave me 22. So I paused there for a second because I had to do that mentally in my head. And then 22, that's still an even number, so I know 2 will go into it as well. So we're going to do the square root of 2 times the square root of 11. Okay? All of these 4 numbers are all prime numbers. They're 2, 3, 5, 7, or 11. So now let's look at these numbers a little more specifically. If I had the number the square root of 2 times the square root of 2 times the square root of 2 times the square root of 11, that should give me 88. 2 times 2 is 4. 4 times 2 is 8. 8 times 11 is 88. So that gives me the square root of 88. So all I've done is gotten 88 and broken it into prime numbers. What I'm going to do now is I'm going to look at those numbers and I'm going to see which ones match. It's kind of like having pairs of socks, assuming we wear matching socks, okay? So, I know some of us don't wear matching socks, but for this activity we're going to. So, the square root of 2 and the square root of 2, those are matching, okay? Those socks match. The square root of 2 and the square root of 11, those socks do not match, okay? So they're going to stay in the radicand. The reason that works is because the square root of 2 times the square root of 2 gives us the square root of 4. The square root of 4 is, in fact, a perfect square. So, we have the square root of 4 times the square root of 2 times the square root of 11. Okay? The square root of 4 equals 2. We know this is a whole 2 because it's a perfect square. A square that has 4 blocks. Has a perfect square. It's a perfect square of 2. So that's going to be 2. And then something a little bit tricky. Anything that stays in the radicand multiplies together. So 2 times 11 is 22. So the answer to our first problem should be 2 square root of 22. Okay? So that's our first problem. So it does take a little bit of work, but I think as you do it more, we're going to get better at it. So let's move on to the next question. I'll leave that up there for a second so you guys can still see the end of it. But let's look at number 3. Number 3, we have the number 22, and we have a variable x to the 9th power. So what we discussed in class this week is that you can actually separate those two things and have the square root of 22 times the square root of x to the 9th power. Okay, we're going to do these problems separately because, again, square root of 22 times the square root of x exponent 9 will still give us the exact same number. So I'm allowed to do that. So the first thing I'm going to do, I see that 22 is an even number, so I'm going to use 2. It's a prime number, and it's the fastest way to our answer. So that's going to be the square root of 2 times the square root of 11. That still gives us 22. Now with our exponents, as with our variables, we are going to break them up looking at the exponent. So there's x with a 9 exponent. So that means that there are 9 x's. So we can also write that as x times 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 x. Now if you guys see on my paper, I have made it so my x's are next to each other. I'm just saving myself the next step. Okay? So what I'm going to do is I'm going to circle the pairs. Okay? I have 4 pairs of x's. I have 4 pairs of socks. And if you look at the number, I don't have any pairs in that number. The 2 doesn't have a mate, and the 11 does not have anything that matches it. So the number in this radicand will remain 2 squared times 11 squared, which is the square root of 22. That's not going to move at all. And then we go to our variables. We have 1, 2, 3, 4 pairs of x's, and those are going to come out as x with an exponent 4. And then if we look close, we have still got one x that did not have a match. The washer must have eaten that sock, and it's got to stay in the house. So that x we'll go right back into this radicand right here, giving us 4x exponent 4 with the square root of 22x. Now a little trick for you guys to know when we're talking about square roots, you cannot have more than one of that type of variable inside of the radicand. You know, you can have numerous variables, so you can have x's and y's and z's, but you cannot have more than one left inside of there. So if you ever see a question that more than one's left in there, you know it's going to be wrong. Okay? So, we're going to go down to the next question, and that one is just using variables. Okay? So, let's do number 4. It's just using variables. Alright? So hopefully this will be a little easier for you guys now that you know just to pair them up and get them out of there. Okay? So I'm going to erase some of this so that we can see it. So we have x to the 5th, y to the 6th, and z to the 3rd. So this is exactly what I was just talking about. You have more than one variable, but you know when we're done in that radicand underneath the square root sign, you can only have a maximum of an x, a y, and a z. And sometimes they all come out. So let's give this one a whirl. We have x's. We have 5 of them. 1, 2, 3, 4, 5. For y's, we have 6 of them. 1, 2, 3, 4, 5, 6. And z's, we have 3 of them. 1, 2, 3. Okay? Now, we're going to look at this radical, and we're going to try to pull out what we can pull out. So I'm going to use my black marker with our x's. We have 1 pair, 2 pairs of x's. So I'm going to come over here and I'm going to say x squared. Square root. There's still 1x left over, so I'm going to put that back with the radicand. The next one is y's. I have 1, 2, 3 y's. 3 pairs of y's. So I'm going to put that right here, y to the 3rd.
Will the custodian please open the bus door for my party? Thank you.
So we have 1, 2, 3 pairs of y's, and there aren't any extras, so nothing goes in the radicand. And then we have z's. We have 1 z, 1 pair of z's, and we have 1 left over, so that goes back in the radicand. Okay? So the answer here would be x squared, y cubed, z, square root x, z. Okay? So it looks a lot more difficult than it is. Notice again, inside of the radicand, both the x and the z are by themselves. Again, with square numbers, they have got to be by themselves in the radicand when you have simplified it. Okay? So let's take one that's a little bit more difficult. Number 5 is about as difficult as we're going to see this year, okay? So let's look at it. We have 450, x to the 49th, y to the 13th, and z to the 10th. Okay? So let's try to break this down. We're going to do it one piece at a time. 450. Okay? 450. When I see a 0 on the end of a number, I always multiply it by 10 because it makes it go down fast. So when I'm taking this radical down, I'm going to say 10, the square root of 10 times the square root of 45. And then my 10 is going to be the square root of 5 times the square root of 2. Okay? These are all prime numbers. Alright? Now we have 45. 45 can be 9 times 5. Square root of 9 times the square root of 5. 5 again is a prime number, so I'm going to circle it. 9 isn't, and that's a tricky one. 9 is not a prime number, so we're going to take it down one more time, and we're going to have the square root of 3 times the square root of 3, and we're going to circle both of those. Now, some of you guys might have already known that square root of 9 was a positive 3, but some of us don't. So these are our numbers now. What I like to do, because sometimes I'm a little messy in math, I'm going to rewrite these numbers again. Okay? I have the square root of 2. That's this one. I have a square root of 3 and another square root of 3. I'm going to cross those off. I have a square root of 5 and a square root of 5 again. Okay? And that's all of them. So I know that if I did 2 times 3, that's 6. 6 times 3 is 18. 18 times 5, I will literally have to write that out, but 18 times 5 is 90. Okay? And 90 times 5 is 450. So I know that those numbers put together give me exactly 450. So I know that I'm on the right track to getting this answer right. So now what I'm going to do is I am going to go in here and I'm going to find all of the numbers that are pairs. Okay? So I have 2 3s and I have 2 5s. Okay? So the 3s come out as 3 and the 5s come out as a 5 because again, the square root of 3 times the square root of 3 is the square root of 9. And I already showed you guys 9 blocks makes a perfect square. The square root of 5 times the square root of 5 is 25, the square root of 25, and that also is a perfect square. So both those are going to come out. And the other thing that doesn't get to come out is the square root of 2. The square root of 2 will then go back into this radicand like so, and it will stay by itself. These two that came out, though, we're going to multiply those together, and we're going to get 15. So we're going to go ahead and put those together, and that gives us 15. Now, with x is 49, okay? So the way we can do this, we can literally draw 49 x's if we wanted to, okay? And that's a perfectly acceptable way to do it, and it would just take us a little bit. So what I'm going to do is I'm going to teach you guys a little trick. But again, you could literally draw 49 x's and pair them up. The other thing we could do is we could divide them by 2 because we know that 2 is going out. We know that every 2 is going out. So we're going to say 49 divided by 2. 2 goes into 4 twice. Okay. Subtract, you get 0. 2 goes into 9 4 times, leaving us 1. So what we have here, and this is a type method, and again, you guys could certainly draw all 49 of the x's and line them up next to each other. But what this tells us is that we have 24 pairs of x's, and one of them will remain. So I can say x to the 24th come out, leaving 1x inside. Okay? Again, notice, you only have a single variable inside. So that's one way you'll always know you're getting it right. Okay? So now let's look at 13. We'll do 13 the same way, just so I can show you it will always work. 13, I'm trying to take them out in groups of 2. 2 goes into 13 6 times. 6 times 2 is 12. 1 remaining. So this means that 6 is how many y's come out of the radicand. So now I have y to the 6th, and underneath the radicand, I have a single y. Okay? So that is another way we could do it. But again, I'll show you with the z's. 1, because it's a smaller number, and 2, because I want you guys to understand you can do it either way you want. With the z's, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 z's. These are in pairs of 2. 1, 2, 3, 4, and 5. That's 5 pairs of z's. Those will all come out of here. We don't have any extra. So I could have divided 2 divided by 10. 2 divided by 10 gives me 5. I would have known that you take z to the 5th power. Alright? So, that's a couple ways that you can do that. Now, this next one is a little tricky. Alright? And this is something we haven't talked about probably enough in class, but I want us to get good at it moving forward, because it's kind of a way to think about these. These can be difficult. But let's looking at 6, it says, what is x square root of 5x equivalent to? Okay? So what they're asking us to do is they're asking us to actually put it back into the radicand. They want it in radical form is another way to say that. So to get 9 out, we would have had to take them out in pairs. So what we're going to have to do to get them back in, we're going to have to put them in pairs. Okay, so what we have here is we have 9x square root 5x. Now, we want this 9 and we want the x back inside. But let's do it with numbers and then we'll do it with letters. So the first thing I'm going to do is I'm going to take 9, I'm going to put it back in. To get 9 back in, it's going to take 2 of them. Not just 1, 2. And the second part you've got to remember is it's going to be underneath a radical sign. Okay? So, now we're going to have, and I'm just kind of blowing this out. I'm going to take these extra variables off for a second. So we have 9 square root of 5. I'm going to get those variables back in a second. 9 again goes in twice. So I'm going to have the radical 5 times 9 times 9. 5 times 9 is 45. And then we're going to do 45 times 9. Well, 45 times 9 is going to be about 450. It's subtract a little bit, but let's make sure it's just right. What I did there is I did a little bit of mental math. I know it's going to be close to 450, but it's not quite 450. So 9 times 5 is 45. 9 times 4 is 36. And you add 4, 46, 47, 48, for 9, 50. Okay? 455. I feel like I did something wrong there. Okay? I have 36. Here's that right. 405. There's my mistake. Okay? So, because I did mental math there, and I knew 450 was not 45 times 10, and when I ended up with 455 there, I knew I did something wrong. I just couldn't remember what it was. So I redid 9 times 4 was 36, and I added 4, and I realized it's 405. That makes sense. That's why we're working on mental math in class. Okay? So 405. So underneath our radical, we have 405. But don't forget about the variables. Okay? Now the variables are going to be similar. Okay? We're going to have to put them back in sets of 2. So I'm going to come back up to this nice blue screen here. Blue in here. And I'm only going to work with the variables this time. This time we're going to put in 1x, 2x's. Because remember, they come out in pairs, so they've got to go in pairs. So that makes it have 1, 2, 3 x's go in there. That would also be written x cubed, or x to the 3rd power. Okay? And so number 6, that's really where we wound up this week. Okay, we didn't do much exponent laws because I really wanted to hone in on this stuff. But let's go over some of these exponent laws. And these are laws that you guys don't know as well. In fact, you probably don't know at all. Okay? But you might remember them from the past. So let's do the ones that we can immediately figure out. The zero exponent rule. Okay, the zero exponent rule, I'm just looking at A, and you could look at it's number 5. The zero exponent rule means that if you have a number to the 0 power, it's always equal to 1. Okay? And so A goes with 5, or 5 goes with A. Okay? So, looking down that chart, we're going to go to the multiplication rule. Okay? So, the multiplication rule means that if you're multiplying 2 variables, you are going to add them. So if you had like 5 to the 3rd times 5 to the 4th, you're going to add those up, so you have 5 to the 7th. So the multiplication rule is E. Okay? That's E. The division rule is just the opposite. Division rule means that you are going to subtract the variables. Okay? Now remember, what we're going to learn is that you can't have a negative one, because if it's negative, you're going to have to flip it down to the from the numerator to the denominator, or vice versa, depending on where the negative variable is. Okay, and again, this is all going to make much more sense next week when we go over these a little bit more in detail. The power of a property rule. The power of a property rule is D. And that simply means that if I'm using parentheses and I'm going like A and B up to a power, that power goes on both A and B. So if the power is AB to the power of 2, then A is going to go to the power of 2 and B is going to go to the power of 2. So number 3, the power rule goes to D. Okay? And the power of a product rule, okay? The power of a product rule is actually, this is a boo-boo on my part. And I'm sorry about that. So 3 actually goes to B. The power of product, and I said it right. What happens is, if you have A to the second power, 2, and then you have a parentheses, and then you have to another power, those are actually going to multiply those together. So the power of a power rule, the power of a product rule, sometimes get a little tangled up, and I just tangled them up. The power of a product rule means that the product goes onto that power, and that would actually be D. So 4 goes with D. Okay? And the last one we need to talk about is the negative exponent. What you're going to find in this unit is you cannot have a negative exponent. Okay? Your negative exponents always will be flipped. So if your exponent is negative on the top, you're going to flip it over to the bottom. And if it's on the bottom, you're going to flip that exponent back to the top, because they cannot be flipped around. So the ones that I get confused, and I got them confused today, is 3 and 4. I'm going to put a star next to them. And again, the power of a power rule, the power of a power property means that when you have 2 variables, let's say you have x is 2 times x is 4, what you're going to do is you're going to multiply those. So you're going to have x to the 8th power. The power of a product rule means that you're going to have parentheses around it, and whatever that power is on the outside goes to both of those variables. So if you had xy, parentheses, variable, and the exponent is 2, then you're going to have x to the 2, second power, and you have y to the second power. All right? So, like I said, 3 and 4 are the tricky ones in my opinion. The one that we tend to get wrong, that's the easiest in my opinion, is the negative exponent. As you were. Not the negative exponent, you flip them. The one that I feel that people get wrong that we should get right is the 0 exponent rule. Remember, if it's to a 0 power, it always equals 1. Okay? So, this one should be a gimme, a 0 exponent, but you've got to remember what it means. The last thing we're going to work on today is a little bit of review. On the test you have on Friday, you're going to have 16 problems. 8 of them are going to be on radicals, 8 of them are going to be in exponent rules, and 4 of them are going to be reviews. Okay? So, the sum of twice a number and 15. So the sum means plus, twice means 2, a number is n, and 12 is the number 12. The sum of twice a number and 12 is simply going to be 2n plus 12. Okay? The way I got that is I know twice n, 2n is twice a number, and I'm adding them because it says sum, so I'm adding the 12. So the second one is very similar, but not exactly the same. This one says twice the sum of, now remember, not always, but often if we see this word of, we are going to use parentheses. Twice the sum of a number and 12. All right? So again, we're using that word sum, so that's where I got that from. But that word of was slipped in there again. And so they're trying to trick you here. And this one should be 2 parentheses n plus 12. Okay? Sum of. Sum of is the collection of a number and 12. So those are in parentheses. That means if we were to distribute it through, it would be 2n plus 24. Okay? Once we did the distributive property. The last one is replacement variables. Replacement variables we did okay on. What we mess up on replacement variables is we tend to mess up our signs. Okay, so we have 5 times x, which is 6 minus 3 minus 3 times negative 1. So I'll put the x in red and the y in black. Okay? So I have put those in. The negative 3, as you were, that is a mistake on my part. The x is actually 6. So I'm going to put the 6 in red minus the 3 minus 3 times the y, which was negative 1. Okay? And what I really should have done there is I should have put this above it. So I'll do that now because that's a really good practice to okay. I really should have done it like that, and then I would have made that mistake. So when we're doing these properties, we've got to do parentheses first. All right, we've learned this. Do the parentheses first. 6 minus 3 is 3. 5 times 3. And then we have minus 3 times negative 1 is negative 3. This is where they're trying to trick you. They're trying to trick you because they have 2 negatives in a row. All right, let's not let it trick you. 5 times 3 is 15. Minus a negative 3 is plus 3. And that gives us 18. Okay? So the answer to this here is 18. All right? So I really hope you guys feel prepared for this test today. On next Friday, I think you guys have done a really great job on the radicals. And next week we'll really hone in on those exponents and we'll get better at those. Good luck. Hope to see you guys in class. Great job on your homework.